Okay, hello everyone. In this video, we are going to discuss about Fourier transform. That means transformation of a function from one domain to another and vice versa. In our last class, we have been discussed in detail about various numericals based upon Fourier cosine integral, complex form of Fourier integral, and Fourier sine integral also. Here Fourier sine integral in detail we have been discussed. Before that, we discussed Fourier complex integral, the expression of Fourier complex integral, and we proved it. And before that we discussed the Fourier integral theorem. So in this particular video where we discussed Fourier integral theorem, in that video I discussed the basic idea about spatial domain, time domain and frequency domain. That means if we have or we are in a particular domain, suppose we are going to consider this example, time domain, I am going to transform to frequency domain. So in time domain, here we can see the two waves in 1 second passed through this particular point. Suppose if I am going to transform this time domain to frequency domain, we can found the at frequency domain, at that means at 2 one line will be observed. That means this wave or this in this time domain we can found one wave having the frequency is 2. Similarly, if we are going to consider this data which is in the time domain, if it will be transformed to frequency domain, then it will observe like this: at 3 one peak, at 6 one peak. That means in this time domain data two frequency are mixed together. So here time and frequency domain are both coupled with each other, and we can transform one form to another by using different transformations your Fourier transform, Laplace transform, and other transformations are there. But in our syllabus you have Laplace and Fourier transformation. Laplace transformation we discussed separately, and here we are going to discuss Fourier transform. Okay, what will be the expression of the Fourier transform of a function, or how we are going to transform one function which is in one domain and it will transform to another domain? What will be its expression? For that, we are going to consider Fourier complex integral of a function fx. Is this much already we have been proved in our previous video. Just now I shown you that this one. Okay, you can watch that video. Fourier complex integral is this much: 1 by 2 pi minus infinity plus infinity e to the power I omega x into d omega minus infinity plus infinity f of t into e to the I omega t dt. These things we have been proved in that video. You can watch that. So same thing I have been written over here, and here in the next step what I done, that 1 by 2 pi I written 1 by 2 pi root over, and here 1 by 2 pi root over. So 1 by 2 pi root over minus infinity to plus infinity, as such I have been written, and this function e to the I omega x d omega, and this one 1 by 2 pi root over this much. These things I have been written in curly bracket. Let this is your equation number 1. So in this equation number 1, if I am going to integrate this one, this integral, then we can found another function which will be function of omega. So from above equation number 1, if we are going to consider this integral and we are going to integrate, then finally we are going to get another function which will be function of omega, because after integration we have to substitute instead of t the limiting values, and here omega will be act as constant. So finally we can get another function, let that is your capital F, and that capital F will be the function of omega. So here no bound to write capital F omega. Some books are written G, some books are written capital G. You can write itself capital T, no problem. But maximum book you can found it is written as capital F. So here small f, which is the function of t, or we can say small f which is in the t domain transformed to omega domain, and that having the function is f. That means here small f transformed to capital F, small f which is in the t domain transformed to capital F which is in omega domain. So simply we can say it is a transformation from t domain to omega domain. Let this is your equation number 2. Okay, now equation number 1 will be fx will be equal to 1 by 2 pi root over minus infinity to plus infinity e to the I omega x e to the minus I omega x d omega, and instead of this we have been written capital F omega. Okay, so from this equation number 3, you can perceive or you can understand that this integration is integrated with respect to omega. If it is so, here x will be act as constant, so the limiting value will be substituted at omega after integration, so x will be constant, so finally we can get a function which will be the function of x. Okay, so here we can say that this function capital F, which is the function of omega or having the variable omega, or we can say this capital F which is in the omega domain transformed to another domain, that is your x domain. Got it? Same thing I have been written. From equation number 3 we can say that this is transformation omega domain transformed to x domain. Okay, now here instead of x we can write t because it is a dummy symbol, symbol. So let x equal to t in equation number 3. As it is a dummy symbol, then equation number 3 will be, instead of x it will be t. F of t will be equal to 1 by 2 pi root over minus infinity plus infinity capital F omega into e to the minus I omega t into d omega. Here I is your iota. Iota means I is your minus 1 root over that, you know. Let this is your equation number 4. So from this equation number 4, what we can perceive or what we can understand that this function which is in omega domain transformed to t domain. Here domain, that is your omega domain transformed to t domain. So here you can see, if we are going to consider this integral, we can say that t domain transformation to omega domain. Here omega domain transformed to x domain. Here omega domain transformed to t domain. Right? This is nothing but called as your Fourier transformation, that is your transformed to one domain to another domain. Okay. Another thing you have to remember that most important, here I written, by considering equation number 2 and 4, equation number 2 and equation number 4. Okay, by considering equation number 2 and 4, if f omega, this capital F omega is called, if I written if, agar capital F omega is called the Fourier transform, in short we can write f dot t of small f of t, then small f of t which is in the equation number 4 will be called as the inverse Fourier transform of capital F of omega. Okay, see, if we have two equations, suppose equation 2 and 4 I have, then we can say one is another's Fourier transform or vice versa. Here same thing I have written, if ft, small ft is called Fourier transform of capital F omega, then capital F of omega will be called as the inverse Fourier transform of small f of t. Okay, small f of t. So if we have the two equations, then we can say that this is the Fourier transform of this one, and this is your inverse Fourier transform of this capital F of omega, what I written in first point. Okay, so for Fourier transform we consider t e to the I omega t integration with respect to t. This is your capital F of omega, function variable t, and this will the plus sign plus iota omega t dt called as capital F of omega. For inverse this will be minus. Okay, for inverse transformation of this capital F of omega will be original one, small f of t. So small f of t will be 1 by 2 pi root over minus infinity plus infinity capital F of omega e to the minus iota omega t into d omega. Okay, so here for our forthcoming discussions, when we are going to discuss the numericals upon this, I consider that this integral is the Fourier transform of this one, and this integral is the inverse Fourier transform of this one. So whenever we are going to consider inverse, we are going to consider minus. When we are going to consider straightly Fourier transform of a function, we are going to consider the plus. But most important, suppose we do not have any type of integral. I have only one integral. Suppose I have only one integral, this one integral. So here we can say that this function is transformed to this one. That means omega transformed to t domain. So here f omega transformed to ft, or we can say small f of t is the Fourier transform of capital F of omega. If I have only one integration, so I can say like this. Okay, because some of the books, they have been considered minus iota omega t Fourier transformation. At the time of Fourier transform, they consider minus iota omega t, and for inverse they consider plus iota omega t, what I written in the second point. Okay, so don't be confused. Simply you just remember, Fourier transform of a function means it is transformed to one domain to another domain. Here t transformed to omega by this integration f of t e to the iota plus iota omega t dt, which will be equal to capital F of omega, and its inverse Fourier transformation is your small f of t is this one, same 1 by 2 pi root over minus infinity to plus infinity. This function we are going to consider capital F of omega into here plus iota omega t, here it will be minus iota omega t d omega. Okay, so I suggest you just remember in this format. But what I written in the note, that is your equation number 2 represents the Fourier transform of f of t. Equation number 4 is the inverse Fourier transform of f of omega, capital F of omega, this point. So here we consider capital F of omega is the Fourier transform or f dot t of f of t, and f of t, small f of t, is the inverse Fourier transform, that is I dot f dot t, in short I written, of capital F omega. Okay, so what are the uses or applications of Fourier transform? That these are the some of the applications that it used. Signal processing, that means I told that it is used to transform time domain to frequency domain and vice versa. In solid state physics, particularly to analyze the reciprocal space, reciprocal lattice to direct lattice, transformation reciprocal to direct to reciprocal, this Fourier transformation is very much essential. And in quantum mechanics, I can say you shortly that in quantum mechanics, in your 5th semester you are going to study, suppose one wave function is in the position space, it can be transformed to momentum space and vice versa by considering Fourier transformation. In detail you are going to study in your 5th semester. Okay, so this is all about your Fourier transform. Now I am going to represent some Fourier transform of some basic functions, representation of Fourier transform of some basic functions, which will be clear your idea. Okay, now suppose we have a function f, small f, variable is small x, that means, and it will be transformed to omega domain, that means x domain transformed to, in the x domain, fx is in the x domain and transformed to omega domain, small omega domain. Then how we are going to write? That means Fourier transform of f of x is nothing but capital F of omega, will be written as 1 by 2 pi root over minus infinity to plus infinity, this function f of x into e to the plus iota omega x dx, and corresponding inverse Fourier transform of this one, I dot f dot t of f of omega, capital F of omega, is nothing but small fx. Inverse Fourier transform of this one will be 1 by 2 pi root over minus infinity plus infinity, this function f of omega e to the minus I omega x into d omega. That means this will be integrated with respect to omega. Here another interesting transformation you can see. Suppose the function is small f of a rectangle. This is a rectangle which is in a rectangular domain. will be transformed to triangular domain. How we are going to write? So Fourier transform of this function which is in rectangular domain will be transformed to another domain. Let that function is capital F triangular domain will be how we are going to write 1 by 2 pi root over minus infinity plus infinity. This function e to the power, the two variables are rectangle and triangle, both will be there, e to the power iota, triangle, rectangle, and integration with respect to rectangle. So if while we do this, then the integration, after integration the limit will be put instead of rectangle. So obviously finally we found another function which will be the function of triangle. So e to the power iota triangle rectangle into d of rectangle. Corresponding inverse Fourier transform of rectangle means it transformed to rectangle. This triangle transformed to rectangle. How we are going to write this one? Capital F function of triangle e to the power minus iota. These two functions will be there, triangle, rectangle, but integration will be with respect to triangle. Okay, another beautiful example I am going to give you. Suppose this is a tree. This is a tree and its corresponding seed. Okay, so we know that from tree we can get seed and from seed we can get tree. Okay, suppose we have this one, that means in seed domain. Okay, the function which is in the seed domain, it will be transformed to tree domain. So this is your tree, this is your seed, corresponding seed. So if it will be transformed to tree domain, that means what we can write? We can write that Fourier transform of seed domain, that is your equal to, we can write, sorry, this is Fourier transform. We can write that capital F function of tree domain, which will be equal to 1 by 2 pi root over minus infinity to plus infinity. This is the function which is in the seed domain into e to the power iota tree domain, seed domain will be there. It will be integration with d seed. Okay, so this is the transformation of seed domain to tree domain. The inverse Fourier transformation of tree domain, that means we can get the seed function in the seed domain. That how we are going to write? 1 by 2 pi root over minus infinity to plus infinity. The function which is in the tree domain, e to the power minus iota tree domain seed integrate with tree domain. Okay, so here this is the Fourier transform of this function, and this is the inverse Fourier transform of this function. Okay, now we are going to consider another function having two variables. Here you have to watch carefully because this point 3 and point 4 is very much essential when we are going to discuss the applications of Fourier transform in your heat conduction, propagation of wave, and another two and 3 applications what we are going to discuss at the end of this topic. Okay, so here suppose the function is small f, which is the function of x and t. This is the two variable x and t, which is in which domain? Xt domain, and it will be transformed to omega t. So if I am going to consider this two variable xt, it is transformed to omega t. That means which variable has been transformed? Here x variable transformed to omega, but t not transformed. t as such is there. t तो ट्रांसफॉर्म हुआ नहीं, सिर्फ x डोमेन ट्रांसफॉर्मेशन हो गया किसको? ओमेगा को. ठीक है, तो हाउ वी आर गोइंग टू राइट? तो हियर फोरियर ट्रांसफॉर्म ऑफ दिस फंक्शन f of xt will be transformed to another function capital F, which is the function of omega t, because this x is transforming to another variable or domain omega, will be written as 1 by 2 pi root over minus infinity plus infinity, the original function. ये original function है f xt, that we have to write into e to the power plus iota omega x into dx. Got it? Most important, इसको याद रखना है कि ये तो x का ही ट्रांसफॉर्मेशन हुआ ना, x का ट्रांसफॉर्मेशन हुआ, हियर x इज ट्रांसफॉर्म टू ओमेगा, सो द इंटीग्रेशन शुड बी with respect to x, but two variables will be there. Here we have to consider the two variable I omega x, t only variable we have to write as such. t यहाँ पे कोई फर्क नहीं पड़ेगा, t will be written as such. Okay, likewise its inverse Fourier transform, if this is the Fourier transform of this function, then inverse Fourier transform of this function, how we are going to write inverse Fourier transform of this function? Obviously it will be small xt, so small xt is nothing but inverse Fourier transform of f omega t. Capital F omega t will be equal to 1 by 2 pi root over minus into plus infinity capital F omega t. Here it will be, carefully you have to observe that e to the minus iota omega x, but this will be integration with respect to omega. This will be integration with respect to omega. t सिर्फ रहेगा, t will be written as such. Here there is no changes of t, only changes of omega to x, x to omega. Okay, likewise if we are going to consider xt fxt, which is in the xt domain, transform to x omega, that means here t changes to omega. Likewise x will be written as such, only t omega will be transformed to one another. So this capital X omega is the Fourier transform, or we can write Fourier transform of small f xt will be equal to 1 by 2 pi root over minus infinity to plus infinity small xt into e to the I omega t dt, and its inverse Fourier transform, this one capital F x omega inverse Fourier transform is nothing but small xt, small f of xt will be equal to 1 by 2 pi root over this one capital F x omega e to the minus iota omega t d omega. Okay, here x is going to write as such. Okay, so this is all about your Fourier transformation of a function. Okay, in our next class we are going to do some numericals based upon Fourier transform. Okay, and finally I am going to suggest to all of you that you just remember, you have a function having the variable t, it is transformed to another domain omega, it will return like this e to the power I iota, this variable will be there, and the another variable to which it will be transformed, that is your I omega t dt. This is called as your Fourier transform of this function. You just remember, I suggest that you just remember equation number 2, which is called as the Fourier transform of small f of t, and its corresponding inverse Fourier transform is your equation number 4. That means inverse Fourier transform of f of omega, capital F of omega, is your f of t. Okay, you just remember these two equations. If you like this video, do subscribe and share. Thank you so much for watching this video. Thank you.